I heard that as vaccination rates in children increased, so did rates of autism diagnosis. Doesn't that mean that vaccines cause autism in children? Actually, no. If both rates change together, they may have a relationship and we may be able to make predictions based on that relationship, but it does not mean that one caused the other. In other words, we can't prove causation from a relationship between two quantitative variables, but we can use statistics to discuss the relationship. Correlation is the statistic that measures the strength and direction of a linear relationship between two quantitative variables. Is there a way to see the relationship between the variables? Well, you can get a picture of correlation by graphing a scatter plot. On a scatter plot, each axis represents a variable. The variable being predicted is plotted on the y-axis and the explanatory variable is plotted on the horizontal, or x-axis. On a scatter plot, each dot represents a piece of data. So, when I look at a scatter plot, I am looking for patterns among all the dots. Yes. For example, do the dots follow a straight or curved line? How similar are the points to each other? Are the points close together or far apart, and are there outliers, or unusual points that are very different from the rest? What is the direction of the relationship? When the values of the variables change together, we say that they have a positive association or relationship, but when they change in opposite directions, for example, when one increases and the other decreases, we call that a negative association. Okay, but how do I statistically describe correlation? You use a regression equation to draw a regression line. The regression line is drawn over the scatter plot and gives the average value of y at any given value of x. It can also be used to predict future values for one variable based on the relationship with the other, known variable. The more points that are close to the regression line, there is a stronger relationship and prediction will be more accurate. How do I write a regression equation? The form of the regression equation is as follows. The predicted value of the response variable, autism rates in your example, is equal to the predicted value of autism rates when the explanatory variable, vaccination, is equal to 0 plus the predicted value of autism rates when vaccination rates change by 1 unit times the explanatory variable, vaccination rates. Or, y is equal to y-intercept plus slope times x. A negative slope indicates a negative relationship while a positive slope indicates a positive relationship. Is there a number that describes direction and strength? Yes. The correlation coefficient, r, is a number between -1 and +1. A negative r means that values increase in opposite directions, while a positive r means that the variables are positively associated and their values will increase together. The magnitude of r describes the strength of the relationship. For example, if r was equal to -1, that would mean a perfect negative association. Okay, so I now understand that when two variables are statistically correlated, they have a relationship that can be described with a scatter plot, regression line, and the correlation coefficient. When there is a strong association, the points on the scatter plot are close to the regression line and the magnitude of r is large. R describes the strength of the relationship and its direction. As r gets closer to a magnitude of 1, the relationship gets stronger. Negative r values show negative associations. One variable increases as the other decreases. That's it. Okay, but I still don't understand how to determine causation. Well, understanding correlation gives us a lot of information. We know how variables are related, how strongly the relationship is, and we can use the relationship to predict future values for one variable based on the known value of another. However, this does not mean that one variable causes the change in the other. In your example, there are many factors that could cause an increase in autism, including better diagnostic techniques. We know there is a relationship, but we don't know if one variable causes the other. What if, because of more comprehensive well-child exams, more children are being vaccinated but more signs of autism are also being caught in clinics? Or if increased autism awareness in schools has coincided with increased stringency of vaccination requirements for school entry, leading to higher vaccine rates. We can't determine causation for these complex variables with multiple confounding factors by simply examining the rates of changes of two quantitative variables. Okay, so how do I know whether a change in one variable is caused by another? Causation can be inferred only for data resulting from a randomized experiment using a random sample that is representative of the population. You cannot base a claim for causation on observational studies. Causation is difficult to prove, so correlation can be statistically proven. Causation is more difficult. There's no simple statistical test to prove causation. Thanks for clarifying. I will look for more evidence to help me decide what I think about the vaccination debate.